This is question set number 3 on average. The first question: the average runs of a cricket player for 10 innings was 32. How many runs he must make in the next innings in order to increase his average by 4 runs? So we know the average runs of the cricket player for 10 innings, which is 32. So 32 is equal to the sum of runs for 10 innings divided by the number of innings, which is 10. So the sum of runs for 10 innings of that player is equal to 320. So we have the sum of runs for first 10 innings. Now to the next part of this question: how many runs he must make in the next innings in order to increase his average by 4 runs, which means that the average is now 32 plus 4 runs, which is 36 runs, which is equal to, we know the formula, sum upon the count. The sum is the sum of runs for 11 innings, so let's name this sum 2, divided by the number of innings, which is 11. So sum 2 is equal to 36 times 11, which is equal to 396. So we have the sum of first 10 innings as 320 runs, and we have the sum of runs of first 11 innings as 396. The sum of runs for first 11 innings will be equal to the sum of runs of first 10 innings plus the sum of runs of the 11th inning, and we have that as equal to 396, and we know the value of the sum of runs of the first 10 innings. So 320 plus S is equal to 396. Remember, S is the runs scored in 11th innings. Therefore the runs scored in the 11th inning is equal to 396 minus 320, and that is equal to 76. So the answer is option D. In the first 10 overs of a cricket game, the run rate was only 3.2. What should be the average runs per over in the remaining 40 overs to reach the target of 282 runs? Well, the average of runs for the first 10 overs is given in this question, and that is 3.2 runs. So 3.2 runs is the average of first 10 overs, which is equal to, we know the formula for average, that is sum of runs for the first 10 overs, let's term that S1, divided by the number of overs, that is 10. So now we can find out the sum of runs which were scored in the first 10 overs. Therefore S1 is equal to 3.2 times 10, which is 32. So we know the runs scored in the first 10 overs. Now it is asked that what should be the average runs per over in the remaining 40 overs to reach the target of 282 runs. So for that we need to find out the runs needed in the remaining 40 overs. So the target is 282 runs, so runs needed is equal to 282 minus the runs previously scored, which is 32, and that is 250. Let us term that S2. Now we have to calculate the average of runs for 40 overs. So average is equal to the sum of runs to be scored in 40 overs, that is this S2, which is 250, divided by the number of overs, that is 40. 0 and 0 gets cancelled out. 25 divided by 4 is equal to 6.25. So the answer is option A. The average of 75 numbers is 35. If each number is increased by 5, then the average of new numbers is. Okay, so we have been given the average of the 75 numbers, which is 35, and we know the formula for average, which is sum upon count. So the sum is, let's say the numbers are x1, x2, x3 till x75. So the sum is going to be x1 plus x2 plus x3 till plus x75. divided by the count. The total number of numbers is 75. So what is the new average if each number is increased by 5? Let us increase each number by 5. So a, which is to be found out, is equal to x1 is increased by 5, then x2 is increased by 5, and so on till x75 is increased by 5, divided by the count is going to be same, which is 75. We can write this as x1 plus x2 plus x3 till x75, plus there are 75 times 5 because there are 75 numbers and each number is increased by 5. So plus 75 times 5 divided by 75. This is the original sum, which is equal to x1 plus x2 plus x3 till x75. So this is sum plus 75 times 5 divided by 75. We can divide the 75 into each of this sum and 75 times 5. So this is equal to sum by 75 plus 75 times 5 divided by 75. This 75 gets cancelled out. We know the value of this, which is the average, that is 35. So it is equal to 35 plus 5, and that is 40. So the new average is 40. The final question. A student's marks were wrongly entered as 83 instead of 63. Due to that, the average marks for the class got increased by half. The number of students are. Let's say that there are n number of students. So when this student's marks are considered as 63, which are the original marks, then the average can be written as A equals to sum plus 63, the sum of rest of the students plus this student's marks divided by n. And when the student's marks are wrongly entered as 83, we have been given the relation between the two averages. So let's say that the new average is A1, which is equal to the sum of rest of the students' marks plus 83 divided by the number of students are same. But in this case, it is given that due to that, the average marks for the class got increased by half. So we can write A1 is equal to the original average plus half. The new average is equal to half more than the original average. So the new average is sum plus 83 by n. The old average is sum plus 63 by n plus half. So this is equal to again sum plus 83 by n equals twice sum plus 63 plus n by 2n. So this n and this n gets cancelled out. This can be written as sum plus 83 is equal to, we can divide this term by 2. So 2 and 2 gets cancelled out. So we can write sum plus 63 plus n by 2. This sum and this sum gets cancelled out. This can be written as 83 minus 63 is equal to n by 2. Therefore 83 minus 63 is 20. Therefore n is equal to 20 times 2, which is 40. So there are 40 number of students in the class.